Welcome to this video on advanced techniques in multiple regression. Today, we're diving into a crucial topic in data science and machine learning: multiple regression and its variations. In this video, we'll cover the following points. First, we'll understand and define multiple linear regression. Then, we'll learn how to use fitted models to make predictions and interpret key components like intercepts and slopes. Next, we'll explore polynomial regression and interaction terms to capture more complex relationships in data. Finally, we'll discuss how to implement these models in Python using the scikit-learn library. Stick around to the end for a quick summary to tie it all together. Let's start by defining multiple linear regression. In essence, it's a mathematical model that uses multiple input features to predict an output. For example, we use a formula where each input feature has a corresponding coefficient that represents its influence on the output. The intercept is the predicted value when all input features are zero. By combining relevant input features and evaluating the model, we can build more accurate predictions. Now, how do we use multiple regression for predictions? Let's consider an example: predicting miles per gallon, or MPG, based on acceleration and weight. The fitted model allows us to estimate MPG by incorporating both positive and negative relationships with these variables. This is a powerful way to understand and quantify how different factors affect outcomes. Next up is polynomial regression and interaction terms. Polynomial regression extends the basic model by including powers of the input features, such as squares or cubes, to capture non-linear patterns. Interaction terms, like the product of two input features, reveal how variables interact in non-additive ways. These techniques allow us to model more complex relationships in the data effectively. For implementation, Python's scikit-learn library makes it simple. Using the linear regression class, we can fit both multiple and polynomial regression models. For polynomial regression, we pre-process the input features using the polynomial features class, which creates the necessary transformations before fitting the model. This approach streamlines the process, making it accessible even for beginners. To wrap up, multiple linear regression helps us predict outcomes by combining several features. Polynomial regression extends this to handle non-linear relationships, while interaction terms account for dependencies between features. Python's scikit-learn library provides efficient tools for implementing these models. Thanks for watching. If you enjoyed this video, please like, share, and subscribe for more content on data science and technology. See you next time.